Aim is, let's analyze a situation modeled by a quadratic equation. All right, great. So, as with everything for the remainder of this remote learning, feel free to pause the video. Please try these things on your own. I'm going to show all the work that goes behind it and explain it, but it really is way more beneficial for you to try things on your own and then come back to this video and see how I do it. It's very possible you do something differently but still correct. So please try this on your own. Don't just blindly follow me, and of course any questions or comments you have, feel free to comment on this video or email me, or anything on Google Classroom would be great as well. Alright, so first things first, equations of two lines and a curve. Write an equation representing the line that passes through each pair of the points. Alright, wow, this is some review from our second unit of the year on linear equations. So, in order to write an equation of a line, that means we're using the equation y equals mx plus b, which means I need to find the slope and the y-intercept. So first, I'm going to stack my coordinates, 3, 3, 5, 5, so I can find the differences in my change in x and my change in y. So both of them happen to be positive too. So that means when I write change in y over change in x, if I want to calculate my slope, that's going to give me 2 over 2, or just 1. Now when I plug that in for m, I get y equals 1 times x plus b, and I can choose either one of these 2 points to plug in to find that y-intercept. So I'm going to choose 3, 3. So 3 equals 1 times 3 plus b, 3 equals 3 plus b, 0 equals b. I just subtracted 3 from both sides there to get b alone. Alright, so my first equation for this part A is just going to be y equals x, because my slope is 1, and 1 times x is just x, and if b is 0, I really don't need to write anything there at all for b. Alright, let's try this next one. Same thing. I already have one of the coordinates written, so let's just stack them like this. -4, 0. My change in x is going to be equal to -4, and my change in y is also going to be equal to -4. So when I write change in y over change in x, again, I'm going to get 1, really -4 over -4, which is equal to 1. And I'm going to plug that in to my slope-intercept form equation. Y equals 1 times x plus b. I'm going to choose 0, 4 to plug in. So plug in 4 for y, 0 for x, and we get 4 equals 0 plus b, or just 4 equals b. Putting it all together, I get y equals x plus 4, because my slope is a 1, so I really don't need to write it. Alright, now solve this equation. Yikes. Okay, so on this side I've got x plus 1, which is really a linear equation, and then I've got over here x minus 2 squared minus 3, which is similar to vertex form for a quadratic function. So we know how to solve when it's just x or just x squared. When I have an x and an x squared, it gets a little more complicated. So I'm actually going to want to simplify this, or really expand it. So I'm going to use the box method real quick. X minus 2, x minus 2, x squared. Alright, because really x minus 2 squared is just x minus 2 times x minus 2. Alright, I'm going to combine all my like terms, and I'm going to get x squared minus 2x plus minus 2x is minus 4x plus 4, and then don't forget that minus 3 on the end there. Alright, so we like to get all our terms on one side. It makes it a lot easier for us to solve. So I'm going to subtract x from both sides. And we get 1 equals x squared minus 5x. 4 and negative 3 are going to combine to equal just plus 1. Then I'm going to subtract 1 from both sides, and I'm going to get 0 equals x squared minus 5x. All right, so we should remember from our factoring unit that, or really a couple weeks ago, I'm looking for something that both of these terms have in common. That would make it a lot easier to solve this equation. So I notice that they both have an x, so I'm going to factor an x out. So now I can write it as 0 equals x. When I take an x away from x squared, I just get x. When I take an x away from negative 5x, I just get negative 5. All right, now we know from the zero property of multiplication, or the zero product law, that if I have two factors being multiplied and they equal 0, that means either one can equal 0. So I can either get x equals 0 or x minus 5 equals 0. Solving for x, we get x is equal to 5 or 0. Either one is valid. All right, so this one obviously is a quadratic, so it's going to take a little bit more time. But really, we always want to try and get everything on the same side here. All right, so number 1 was a little bit of a review from our linear unit. And then number 2 is just some more review solving for x. All right, now let's get into the real world problems. 24.2, the dive. The function h defined by h of t equals negative 5t squared plus 10t plus 7.5 models the height of a diver above the water in meters. T seconds after the diver leaves the board. For each question, explain how you know. All right, how high above the water is the diving board? Well, h of t represents height in meters. T represents seconds. So if I want to know how high it is, I'm really looking for something in terms of y. That's my h of t. And 7.5 here happens to be my y-intercept or initial value. So if you're going to dive off a diving board, where you're going to start is going to be how high that diving board is off the ground. So I can say 7.5 meters, since 7.5 is my y-intercept. All right. When does the diver hit the water? All right, so this is really asking you, what is the height of the diver when he hits the water? So we always assume that anytime we're talking about ground level, that water is going to be at the same height. So my height when I hit the ground or hit the water is going to be 0. So all right, 0 equals negative 5t squared plus 10t plus 7.5. Now, it would be nice if we could just factor it like we did in the first problem here, but this is a much more complex equation. So we're going to use the quadratic formula. So as much as I would love to sing it, I'm just going to write it out. All right, so x equals negative b. Oh, maybe I'll sing it in my head. X equals negative b. All right, yeah, laughing at my own jokes. That's funny. Negative b. So let's just write out what a is. A is negative 5, b is 10, and c is 7.5. So x equals negative b, will be negative 10, plus or minus the square root of b squared, that's 10 squared, minus 4ac, so 4 times negative 5 times 7.5, all over 2a, so all over 2 times negative 5. All right, so I'm going to break that up into parts and do that on my calculator. And I'll bring that up here. The easy part I'll just do in my head. This obviously is negative 10 over 2 times negative 5 is also negative 10. All right, so the stuff inside the radical is going to be a little more complex. So that I will take out my calculator for. So always using parentheses, 10 squared minus, and make sure you use the minus sign, not the negative sign. Minus 4 times negative 5 times 7.5. And of course, if you have any problems with your calculator, please send a picture. Say, Mr. Benak, I don't know why I'm getting this error message. All right, So we get 250 for that. So plus or minus radical 250. All right. So when does the diver hit the water? I'm going to get two answers. Obviously, only want to keep one of those two answers. So I'm going to separate this now into my two equations. I got more space over here, so I'll do that here. And I'll write negative 10 plus radical 250 over negative 10, or I could have negative 10 minus radical 250 over negative 10. And I'm going to do those each separately on my calculator. Here's how I'm going to input the first one. Negative 10 plus radical 250. Close my parentheses. All right. Obviously, it's an irrational number because 250 is not a perfect square. Then I'm going to divide by negative 10. All right. And that is not a possible answer, but I'm going to write it out anyways, because how could he have hit the ground half a second ago, right? That doesn't make any sense. All right, so I'm going to do the same thing. So how I just did that, by the way, if you press the second button and then enter, it uses this mode entry, which just means it's going to pretty much copy and paste what you put in like a couple lines ago. So if I do it once, oh, it's actually, so going back too far now, I used it too many times, so I'll have to rewrite it, but that's how I got that initially. I'll show it again later. All right, so negative 10 minus radical 250. Great, and then I'm going to divide that by negative 10. And now I get a number that makes more sense. 2.5811 seconds. Great. All right. How do I know? Well, we talked about that. When he hits the water, the height is 0 meters. So that's how we were able to write that equation. All right, great. Back page. All right. At what point during her descent? Oh, wow. I just assumed the diver's gender. Clearly talking about her. During her descent towards the water, is the diver at the same height as the diving board? Well, we just assumed the height was 0 when they hit the water. Now they're saying they want the height to be the same as the diving board, aka 7.5 meters. So now I'm just going to write 7.5 is equal to negative 5t squared. Let's see, what was that equation? Plus 10t plus 7.5. All right, we want this side to be 0 in order to use our quadratic formula. So write minus 7.5 minus 7.5. So 0 equals negative 5t squared plus 10t. Now, it was actually very nice that those canceled out, because now I'm left with two terms that both have that t variable, so we can use the method we used in the first problem. I'm going to factor out a t. If I take a t away from that, it becomes negative 5t. If I take a t away from that, it becomes 10. And actually, I probably could have factored out even more. I could have factored out a negative 5 or a 5 from each term, because those are also common factors, but I've factored it enough now that I can write my two equations. So either 0 equals t, or negative 5t plus 10 equals 0. Well, really, I should have written that original one the same way. Either t equals 0, or negative 5 plus 10 equals 0. All right, so solving for t, subtract 10 from both sides. Negative 5t equals negative 10. Divide both sides by negative 5. And we get t is equal to 2. So, after 2 seconds, her height is the same as the height of the diving board. Why does that make sense? Well, when she hasn't jumped yet, she's standing on the diving board, so that makes sense that she'd be at the same height as the diving board. All right, great. When does the diver reach the maximum height of the dive? All right, so when we talk about maximum height, we're talking about the vertex. Okay, so how do we find the vertex of a graph? Well, we complete the square from our original function. So if I have h of t equals negative 5t squared plus 10t plus 7.5, right, I'm going to isolate my first two terms. I also need to get rid of that negative 5 in the front, so I'm going to factor it out. So we got h of t equals negative 5 parentheses t squared. When I divide 10t by negative 5, we get negative 2, so negative 2t. And I don't care about that 7.5 at the end. I'm going to leave that out. Now I'm going to use the box method to find out what's going to make that a perfect square. So I know there's a t squared there, and I got to break up negative 2t between these two boxes. That's negative t and negative t. So what times t is negative t? Well, negative 1. Right. Now negative 1 times negative 1 is positive 1. So 1 is the perfect square term I want to add in here. All right, but really, I didn't add a positive 1 to this side. So if I add 1 here, that's not really balancing it. Because I have this negative 5 factored out, I've really done plus 1 times negative 5, which is the same as subtracting 5 from both sides. So it's really h of t minus 5 on this side. All right, now I'm going to rewrite as a perfect square binomial. H of t minus 5 equals negative 5 t minus 1 squared plus 7.5. I get t minus 1 squared because here I multiplied t minus 1 times t minus 1, aka t minus 1 squared. Now I'm going to convert this into vertex form. Just by adding 5 to both sides, I get negative 5 t minus 1 squared plus 12.5. All right, so this is nice because now I know my vertex. My vertex is 1, 12.5. So since x here represents time, I know that after 1 second, the diver reaches a max height of 12.5. And let me make sure I get my units right. We're talking about meters. 12.5 meters. All right, great. Okay, are you ready for more? Another diver jumps off the platform, off a platform rather than a springboard. So I guess that just means that like a diving board will bend, whereas in this case it's not going to bend. So I guess maybe you don't get as much of a leap. All right. So the platform though is also 7.5 meters above the water. So that's telling me that that's my initial value still. But this time the diver hits the water after about 1 second. So that means one of my x-intercepts is going to occur 1 second after, or when t equals 1. So I'm going to write an equation that would approximately model her height over the water, h, in meters, t seconds after she has left the platform. Include the term negative 5t squared, which accounts for the effect of gravity. Okay, so basically what this is telling me is that if I write this equation again, I know my first term is going to be negative 5t squared still, but I don't know anything about my second term, so I'm going to write, let me move this up, plus bx, right? When we don't know that middle coefficient, we just call it b. We still know that it's 7.5 meters above the water, so I'm still going to put that plus 7.5 here. All right, so now we're talking about when the diver hits the water. So we discussed in the last problem that means that h of t is 0. All right, after 1 second,